dspy's declarative programming model leverages signature-based abstraction to encapsulate input-output behavior, with the dspy predict module serving as the foundational building block for composing LM-driven programs. This paradigm enables clean separation between task specification and execution, where signatures define semantic roles while modules handle prompt construction and LM interaction. We're about to examine how conversation history management integrates with this architecture, demonstrating the initialization of a QA signature with history tracking, the instantiation of a predictor module, and the strategic use of few-shot examples to enhance contextual reasoning. The code will reveal how dspy.History maintains state across interactions while preserving compatibility with standard prompt formats. Import dspy. dspy configure elm equals dspy lm OpenAI / GPT-4o mini. Class QidSpy signature. Question SDR equals dspy input field. History dspy history equals dspy input field. Answer SDR equals dspy output field. Predict equals dspy predict QA. History equals dspy history messages equals. Predict dmos append. dspy example. Question equals what is the capital of France? History equals dspy history. Messages equals question what is the capital of Germany? Answer the capital of Germany is Berlin. Answer equals the capital of France is Paris. Predict question equals what is the capital of America? History equals dspy history messages equals. dspy inspect history. This code demonstrates how to enhance a QA system using few-shot examples with conversation history in dspy. The pattern shows how to incorporate historical context into predictions while maintaining compatibility with standard prompt formats. The implementation uses a dspy signature class to define the QA task with question, history, and answer fields. A dspy predict module is instantiated with this signature, and a demonstration example is added to predict dmos to provide contextual learning. The example includes both the current question and a history of previous interactions, showing how to structure multi-turn conversations. When making predictions, the history is passed as a dspy. History, object containing a list of message dictionaries. The key insight here is how dspy handles conversation history in few-shot examples. Rather than expanding the history into multiple turns in the prompt, it represents the entire history as JSON data within a single turn. This approach maintains compatibility with standard formats like OpenAI's while still providing the model with relevant context. The trade-off is that the model receives the history as structured data rather than natural conversation flow, which may affect how it processes contextual information. This pattern is particularly useful when you need to provide examples with conversational context, but want to maintain prompt format consistency across different LM providers. Let's break it down. Import dspy. Imports the dspy framework, providing access to its language model programming tools and modules for building AI systems. dspy configure elm equals dspy lm OpenAI / GPT-4o mini. Configures dspy to use OpenAI's GPT-4o mini model as the default language model for all subsequent operations. This sets the global LM provider that will be used by any dspy modules or signatures unless explicitly overridden in a specific context. Class QidSpy signature defines a class QA that inherits from dspy signature, establishing a declarative specification for a dspy module's input-output behavior. This creates a signature template for a question-answering task, where the class name QA indicates the semantic role of the module. The inheritance from dspy. Signature means this class will be used to declare and initialize the behavior of a dspy module focused on QA tasks, with field names that matter semantically, e.g., distinguishing between questions and answers.
Question, str equals dspy, input field.
Creates an input field named question with string type annotation using dspy's input field class. This defines a signature field that will accept string inputs, typically used to specify the expected type and role of an input parameter in a dspy module's declarative specification. The field name, question, serves as a semantic identifier for the input's purpose in the module's behavior.
History, dspy, history equals dspy, input field.
Creates an input field named history of type dspy, history for storing conversation history in a dspy signature. This field will contain a list of message dictionaries tracking interaction metadata like inputs, outputs, and token usage.
Answer, str equals dspy, output field.
Declares an output field named answer with string type annotation using dspy's output field class. This creates a typed field that will hold the output value of a dspy module, where the field name answer semantically describes its role in the signature. The type hint str indicates this field expects string values, while dspy output field initializes it as a dspy output field that can be optimized during compilation.
Predict equals dspy, predict QA.
Creates a predict instance of the dspy. Predict class configured with a QA signature, which will be used to perform question answering tasks by leveraging the specified language model behavior. The QA signature defines the input-output structure for this prediction module.
History equals dspy, history messages equals.
Creates a history object named history with an empty list of messages, initializing a conversation history tracker for dspy language model interactions.
Predict dmos append. Dspy, example.
Appends a new dspy, example, instance to the dmos list of the predict object. This creates a demonstration example that will be used for few-shot learning or in context examples, where the dspy example encapsulates input-output pairs to guide the language model's behavior during prediction tasks. The line shows the beginning of constructing such an example, though the specific input-output fields aren't visible in this segment.
Question equals, what is the capital of France?
Assigns the string, what is the capital of France, to a variable named question. This creates a simple string variable that will likely be used as input for a dspy module or signature later in the code.
History equals dspy, history.
Creates a history variable as an instance of dspy. History, which is used to track and manage conversation history in dspy, including inputs, outputs, and metadata for LM interactions.
Messages equals question. What is the capital of Germany? Answer. The capital of Germany is Berlin.
Creates a list named messages containing a single dictionary with two key value pairs. Question mapped to the string, what is the capital of Germany? And answer mapped to the string, the capital of Germany is Berlin. This represents a single question-answer pair in a structured format, likely intended for use in conversation history or training data.
Answer equals, the capital of France is Paris.
Assigns the string, the capital of France is Paris, to a variable named answer. This creates a simple string variable that stores a factual statement about France's capital city.
Predict question equals, what is the capital of America? History equals dspy, history messages equals.
calls the predict function with a question about America's capital and an empty conversation history. The dspy.History object is initialized with an empty messages list, indicating this is the first interaction in the conversation. The function will process the question and return a response, potentially using the language model's knowledge to answer the geographical query.
dspy.Inspect History
Calls the inspect history function from the dspy framework to display the interaction history of the current language model, including inputs, outputs, token usage, and metadata. dspy's declarative approach shines here by cleanly separating task specification from execution. The QA signature defines semantic roles: question, history, and answer, while the predict module handles prompt construction and LM interaction. This separation becomes particularly powerful when managing conversation history, where the history field maintains state across interactions without breaking compatibility with standard prompt formats. The key insight is how dspy handles few-shot examples with conversational context. Instead of expanding history into multiple turns, it represents the entire history as structured JSON data within a single turn. This maintains consistency with formats like OpenAI's while providing the model with relevant context. The trade-off is that the model receives history as structured data rather than natural conversation flow, which may affect contextual processing. This pattern is especially useful when you need conversational context, but want to maintain prompt format consistency across different LM providers. The implementation demonstrates how to initialize a QA signature with history tracking, instantiate a predictor module, and strategically use few-shot examples to enhance contextual reasoning. The example shows how to structure multi-turn conversations, with the history passed as a history object containing a list of message dictionaries. This approach ensures that the model has access to relevant context while maintaining compatibility with standard prompt formats.
The history remembers answers it never heard, while the predictor forgets questions it just asked.